The next property that we're going to learn is the quotient of powers property. Now let's do some exploring with it first of all. Let's see if there are any shortcuts for the quotient of powers property that we can take. Even if you already know it, we're going to explore. Yes, Cody?
I think I know what we can do for A. I think.
Okay, what does 4 to the 5th mean, Cody?
1 to the 7th.
No, what does 4 to the 5th mean?
4 to the 5th means 4 times 4 times 4 times 4 times 4.
So 5 factors of 4. Okay. Looks like I got to calibrate again. What do I do, huh? And then 4 to the 2nd power means
4 times 4.
4 times 4. So write this out, please. Because we're exploring right now. We're going to say, maybe there is a shortcut we can use so we don't have to do this every single time. But if all else fails, if we can't remember the property, we can't remember the shortcut, we can always do this. When we have all multiplication, no addition or subtraction going on here, we can cancel, can't we? So we got this 4 that can cancel with one of the 4s downstairs. We have another 4 that could cancel with that one. But now we're out of 4s downstairs, so we can't cancel anymore, can we? So what does this actually, we have 3 factors of 4, so what does it turn out to be? 4 to the 3rd power. We're going to learn how to say it, right? 4 to the 3rd power, or 4 cubed, right? Okay. So let's take a look at the next one. Let's just do it as what it really means and how much can we cancel. And so we have x to the 7th power, which means what? What does that mean?
X times x.
Yeah, 7 factors of x, right? 7 factors of x. And then downstairs in our denominator, we have x to the 5th, which really means how many factors of x? 5. Well, we can start going canceling happy, right? We can go crazy. What's up, ladies? Do you want to share? Because we'll just record it. Anything? Anything you want to share? Yes?
I just said I think I figured out.
Oh, you think you figured out the pattern already? The shortcut? Anybody else think they've got the shortcut figured out also? Oh, okay. Well, maybe I'll let you share it with us here. What is this? What's the result of this one? X squared. Okay. So, Tori, what do you think the shortcut is? Subtracting. Subtracting what? The what? Fate? A fate. Also known as fate?
You subtract the top exponent from the bottom exponent.
Take the top exponent from the bottom exponent. So that would mean take 7 from 5. What is 5 take away 7?
2.
Negative 2. Did we end up with a negative 2?
No.
Noah?
Take the smaller exponent minus the bigger exponent.
Take the smaller exponent minus the bigger exponent. So we'll just always do it in that order because we want to end up with a positive number. Is that what you're thinking?
Yeah.
Huh. Clara?
Shouldn't it be when like the 7 and the 5, when there's leftovers on the top, then that means positive?
Okay. So we did end up with a positive, didn't we? There was leftovers on the top and we ended up with a positive exponent. Same thing in A, right? We ended up with leftovers on the top and we ended up with a positive exponent. I'm going to give Aurora the chance to, I think she's got this figured out how she should have said it.
You take the bottom exponent, subtract it from the top.
Yeah, so you subtract the bottom one from the top one, or at least that works both of these times, right? So we end up with the bottom one from the top one, or in other words, start at the top and subtract the bottom one, right? 5 take away 2, is that 3?
Yes.
And 8. How about 7 take away 5, is that 2?
Yes.
So without using if we actually were ready to use the shortcut on this one, what do you predict the answer is for C then?
3
to the
3
negative 1 power.
to the negative 1 power? Okay. Well, let's, but what?
One would just be positive one.
Okay, because,
Well, when you think of the picture, you go X, like you X out that one and that one and you have one left.
okay,
Not
I figured it out.
Noah?
It would be 3 to the negative 1 power, and your answer would be 1 over 3 to the 3 over 3 to the 1 power.
Okay. How, remember that theory that we're gonna take the bigger exponent, subtract the smaller, can we go with that anymore? Because we like it that way, we wanna take the 3 and subtract the 2 and get a positive 1, can we just do that and say it's 3 to the positive 1 power? Cody?
You always have to subtract the bottom one from the top.
You always have to subtract the bottom one from the top, always. Well, you know what, let's do this like, what we've been doing, let's actually do what it means. 3 squared means 3 times 2. 3, I mean, right? Not 3 times 2. 3 times 3. And 3 to the third power means 3 times 3 times 3. And now we can do some canceling, right? Up and down, up and down. Well, when everything cancels on the floor, like here everything was canceling downstairs. What's really left downstairs after everything cancels?
1.
There's really a 1. There's really a 1. Something divided by itself would be 1 over 1 would be 1. So when everything canceled upstairs, we can't just leave the upstairs empty. You can get away with not putting it when it's downstairs because anything divided by 1 doesn't change it. So you can just ignore it. But if the 1 ends up upstairs, it's got to be there. So this would be 1 over 3. Wouldn't it? It'd be 1/3. 1/3 is the same as, also known as, aka, also known as 1 over 3 to what power? First power. Also known as, why am I making my A's different all of a sudden? Okay. Also known as, what? When, Cody?
3 to the negative first power.
Yeah, because when something's on a floor, it can move to the other floor and become the exponent I'm talking about can become its opposite. So 3 to a positive 1 power downstairs is really the same as 3 to a negative 1 power upstairs. So now is our theory that we are going to have to subtract the downstairs from the upstairs always. Think we can say always? Okay. But I think we are going to have to add in just like one little thing there. We're going to have to make sure we aren't caught doing, because we learned this with multiplying powers. Let's look at this one right here. What does a to the 4th power mean?
A times A times A times A.
And what does b to the 3rd power mean? B times B times B. Okay. Can we cancel?
No,
Why not?
they're not the same variables.
Not the same base.
Yeah, they're not the same base, are they? They're not the same factors. If they're not the same factors, we can't do any canceling. So can we simplify this one?
No. No, we can't because there's no base.
You can.
Can we make it AB to the 1st power?
No, you make it A to the 4th times B to the negative 3rd power.
What?
Is that simplified, class? Yeah. Is that simplified? No, because it's
You're
not
still gonna
simplified
get-
when what? Yeah. So this is another name for what, this is really another name for this. You're right, Cody. That's another name for this, but that's not simplified, is it? Well, now we'd have to say, well, oh, wait a minute. Now we have to rewrite that as 1 over b to the 3rd power, and guess where that b to the 3rd power is going to end back up at? Downstairs, right? So we're just going to leave it just like it is. It just can't be simplified. No reason to change it to b to the negative 3 power, because now we just unsimplify it. This made matters worse. So guess what? If the bases aren't the same, we're not going to be able to apply that little shortcut we kind of discovered along the way, are we? The bases have to be the same. So if the powers have the same, whoopsie, have the same base, if they have the same base,
Subtract the
then we can
exponents.
subtract the exponents. And does order matter in subtraction?
Yes,
Yes, and we decided we're gonna take what?
the top. of the
Top,
bottom,
subtract the
bottom.
bottom. So you might wanna add that in your notes too, to remind yourself, I have to start with the top exponent, and I have to subtract the bottom exponent if I'm gonna take this shortcut. So here's how we will show our work today. Okay? 3 to the 9th divided by 3 to the 5th is the same as, using our shortcut, 3 to the
Fourth power.
9, take away 5, because that's what you did to get 4, didn't you? In your head. So you're going to show me that. It can be 3 to the 9 minus 5, instead of having to write out 3 times 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 3 times, and then 3 to 3, and start canceling. That's a whole lot of work. We could just write this instead. And we say that is really 3 to the 4th power. Is it simplified?
Yes.
You know, it doesn't have a negative power. It does not have a 0 power. But can we we keep going and evaluate this? What is 3 to the 4th power? Well, we just decided a while ago that 3 to the 3rd power is 27. So 3 to the 4th power would be 81. Takes 27 times 3 and we get 81. Without our calculators, we can get that. Even if you have to use your powers table, you don't know what 3 to the 4th power is, I get it, it's okay, then go to your powers table. Okay, you show work for the next one. What would your work look like for number 2? Okay, Devontae, what does the work look like for this one?
4 to the 5th minus 7.
Okay, 4 to the 5th minus 7, like that. Okay, and that becomes what? 4 to the negative 2 power. 5 minus 7. We don't need to jump through too many hoops at the same time, one hoop at a time. 5 minus 7 is negative 2. But now is this simplified? No. How would we rename this now? 1 over 4 to the positive 2 power. And we can actually evaluate this one. We know what 4 squared is. It is what? 16. So now we say this is the same as 1/16. It doesn't become 16. That 4 squared was downstairs, wasn't it? So it's 1/16. Okay, let's just check this out on our calculator and make sure it works. Okay, let's just double check this. I think the first thing I want you to do in calculators is this. I want your calculator to show what the decimal name is for 1/16. What's 1 divided by 16? Have that showing in your calculators. That's 1 divided by 16. So what's the decimal name? Anybody want to call it out for me? 0 point something. 0.625. Like that? That's the decimal name for 1/16. Okay, now what I want you to do is I want you to put into your calculators 4 to the 5th power divided by 4 to the 7th power equals, enter whatever you gotta do, and you get either 1/16 because your calculator is set to give you fraction answers, or you get 0.0625 for 1/16 decimal name is. So, did we do it right? Okay. Anybody have any questions? So this is how we're going to give our answer. Not like this, because what does that tell me you did? Use your calculator. Well, and then some of you say, well, I can use my calculator here, whatever, because it gives it as a fraction. No. This is what I need to see along the way, don't I? This is your processing that gets you there. It shows me you didn't just put it in your calculator like we just did. Yes, Cal?
Okay, I did 4 and then 4 to the 7th power minus 5, and got 4 to the 2nd power and then equals 16.
Okay,
Instead of doing all that.
and you're saying that your answer is 16, and our answer is 1/16, and all is well. Your answer is as good as ours is.
Well, it would be 1/16, just I went the short way.
You went the short way.
Yep,
Oh,
yep.
you messed up. You're supposed to do it in order. 4 to the 5th
Well-
minus 7.
I was just wondering if they had the same answer.
How did you get the same answer? That's what I can't figure out. I'm so confused because if you do this, is this what I'm understanding you did? Then you got this.
Yep.
And then that is this. But yeah, you got the same answer. Is that what you're saying? Do you agree, Buzz? Does he have the same answer as us?
You done good?
Oh, no, you don't get to call anybody dumb. No.
He said done. Like,
Done.
you've done something. He said
Oh.
you've done goofed. Like you've done goofed
Done,
up.
moved. Okay, sorry. Okay, but we don't need to, how, can you justify how that's the same?
No, I'm wrong. Continue class.
But now here's the deal. No, I'm not wrong.
No, keep going.
No,
I want to do it.
you want it or don't?
I want to.
Oh, you want it, but you just think that maybe there's this. If we just stick a fraction bar to 1 because you look over at your neighbor and that's what they've got, then mine's the same thing. Okay, now here's the deal though. If this is your work, Kelvin, I just need to clarify something for you so you're not mad at me on assessment day. Okay, here's your work, but yet here's your correct answer. Am I going to take any points off for having the right answer? No, I'm not. But am I going to take any points off for this?
Yes.
Yeah, I am, because I'm be like, that's not right. Okay, that's all. Okay, we're done. Yeah, you're right. We'll move on. Okay, moving on to the next one. What do you think how we should start this one? Cody?
You should change it, or you should start with x to the 6th power over 1 times 1 over x to the 3rd.
Okay, so in other words, you're going to make the x to the 6th power into a fraction so that we can,
Add them together so that we can get
well, we're not
x.
going to add them together, we're going to
Get them to
yeah,
combine.
do the multiplication, right? Yeah, so 1 times x to the 6th is
X to the 6th.
x to the 6th, and x cubed times 1 is
X cubed.
x cubed. So I can rewrite that like this, right? Before we even try to do our division. We got to do our multiplication problem first. Now we'll go to doing our division problem. So this one we would do x to the what?
6 minus 3.
6 minus 3. Always start upstairs. I don't care what number's up there. Start upstairs and subtract the bottom exponent, which is what?
X to the 3rd.
X to the 3rd power. Okay, are we done?
Yes.
Justify why.
Because the exponent's not
No
negative.
negative exponent. There's no zero exponent. Can we evaluate? No, x cubed is going to have to stay x cubed, isn't it? Because we don't know what x is. We don't know what to cube. So we're going to have to leave it x cubed. Okay, you go ahead and try the last one on your own. I would suggest you do the multiplying first, then the dividing. Property do we have to apply in our multiplication right here? What property do we have to apply? What are we actually doing there? Multiplying
Exponents.
powers. Multiplying powers that have the same, no,
Alright.
same base. We're multiplying exponents that have the same base. When we are multiplying powers, not exponents, when we're multiplying powers that have the same base, our shortcut is to add the exponents, right? Okay, so we end up with 2 to the 6th upstairs. Do you agree with me on that? Is it 2 to the 6th or should it be 2 to the 8th? 2 to the 6th, yeah. It's a power to a power that's the multiply exponents. And we're taking a power times a power with the same base, we add their exponents. 2 factors of 2, 4 more factors of 2, all together we end up with 6 factors of 2. Now we have a division, we have a quotient of powers. Our shortcut for that is take the top exponent, subtract the bottom exponent, we end up with 2 to the third. Are we going to leave our answer like that?
No.
No, we know what 2 to the third is, don't we? What is it?
It's,
6.
no,
It's 8. Not 2 times 3, is it? It's 2 times 2 times 2, yeah. It becomes 8. Okay, that's all folks, we're going to put there today. Okay? Anybody have any concerns before I get to your, okay, get out a sheet of loose leaf paper. You're going to show your work on. Okay, so on that list, like, go ahead and put your name and that is number 32. This worksheet's actually going to be 2 assignments. It's going to be 32 and 33. So we want to make sure that on our loose leaf we're keeping track of which one's which. So on your loose leaf, put your name and number 32. And you're going to do the highlighted problems on this. I'll make sure if they didn't show up real well, but I'll make sure that I go through with you and you know which ones are supposed to be the highlighted ones. So, up in the corner of this right now, if you want, you can put 32 and 33, because it's going to become both. But on your loose leaf, that's where you're going to keep track of which one was 32 and which one was 33, okay? So, this is really 2 assignments today. We're doing the 32 part, which is the highlighted ones. So, can anybody tell me where the first highlighted ones are? Can you tell? You gotta look real close. 1 through 8. Yep, 1 through 8 are the first ones. So if you even want to put this down on your loose leaf paper to make sure that you do all the ones you're supposed to. 1 through 8. Okay, where are the next highlighted ones?
17 to 22.
17 through 22. Notice it doesn't go through 24, just through 22. So 17 through 22 are the next highlighted ones. And now they're kind of random from there. There's 3 more of them. What are they?
26, 28, 29.
26, 28, and 29. Those are the problems we're tackling today, okay? So that's 8, and then 6 more is 14, and 3 more is 14 plus 3 is
22.
17. 17. You should have 17 problems done by the time you're done today. 14 plus 3 is 17. 1 through 8. 17 through 22. 26, 28, 29. This is number 32. Okay, anybody else have any concerns, questions before you spend your time working here? You know what kind of work to show, you gotta show the kind of work we did in our notes. Use the shortcut word though, it's taking less time really. Oh. Okay, who's our noisemaker here?
You.
Feel free to quit.
Alright.
Thank you. You wanted to do homework, that's what it's time for.